Hello folks. So in this video, I'm going to cover the basic building blocks of TensorFlow, which are tensors. And you will get detailed knowledge of what tensor is, what are the important characteristics of tensors, which we need to remember always. So by the end of this video, you will have a good amount of knowledge about these building blocks. And once this concept is clear to you, then it will be a lot easier for you to design the neural network, so thereby ensuring what type or which dimension of data you need to pick or transform in order to or into, so that the neural network model can read that data easily. So folks, this is Nitin, who is on a mission to democratize artificial intelligence, big data, Hadoop, cloud computing, and blockchain to the entire world. And with this aim, I am creating, in fact, regularly creating the associated content and publishing it as well on the periodic basis in order to make it available for the entire community who wants to learn these modern technologies. And you can subscribe to my channel or press the bell icon in order to keep on getting these the latest updates regarding the hottest technologies of 21st century. You can also follow me on Twitter and Facebook at the links given above. And I have also added subtitles in languages like Hindi, English, and French for your convenience, so you can enable them as per your needs. So let's get started. Folks, let's revisit our previous videos where I explained, that each neural network computation in TensorFlow is presented or represented by a directed acyclic graph or DAG. Okay, so these DAGs contain nodes and edges. So data items which flow between nodes are called tensors, or we can say that tensors are edges on our computation graph. Now, as I told you earlier, nodes represent computations or transformations. Okay, and tensors are data which has multiple dimensions, like array of arrays, or we can say that tensors are primitive values which are shaped into an array of number of dimensions. And primitive value can be depicted by int or float values or any other data types, right? So these primitive values are collected in some kind of container called array, and that array can have a number of dimensions, and or any number of dimensions or any shape, right? So now these tensors move between nodes of computation graph, and that's why we have given or the Google has given it a name as tensor flow, right? Moving on, scalars are referred as zero-dimension tensors. For example, let's consider we have a float value like 100.56, string character, let us say B, or int value 9. So these are all represented as scalars and are considered as zero-dimension tensors. Moving on, vectors are one-dimensional tensors and are represented as one square bracket at each end. Okay, so one square bracket at each end, and between these square brackets we have a number of elements. Okay, so moving on to metrics. Metrics are considered as two-dimension tensors, which has row as well as columns, and these are represented by two square brackets at each end. So essentially, number of square brackets at each end represent number of dimensions. So if we have n-dimensional matrices, then we can say that we have n-dimensional tensors, okay, and therefore represented by n pairs of square brackets. Now, folks, these tensors have three defining characteristics. Number one is rank, which represent a number of dimensions in it, right? And the number two characteristics is shape, which represents the number of elements in each dimension. And the third and the last characteristics is the list. In the list is data type, which represents data type associated with each element in the tensor. So as we discussed earlier, rank of the tensor can be thought of as the number of pair of square brackets we would utilize in order to define the specific tensor. So scalar are the tensors of rank 0, vectors are tensors of rank 1, and array is the tensor of rank 2. And tensors which have rank higher than 2 are referred as n-dimensional. Okay. If we let's move on to shape. So shape is the characteristics which tells us how many elements exist in each dimension. Okay, so please note that shape in itself is a vector. Okay, and it contains one element corresponding to each dimension in the tensor. For example, vector of scalar value is empty vector. Okay, and the shape vector of any vector will contain only one element, and the shape vector of matrix consists of two elements, that is number of elements in each dimension of two-dimensional matrix. And for n-dimensional vector, the shape vector will be n number of elements. Okay, and the last characteristics we are going to explain is the data type, which are in fact known to anyone who has studies databases at any given point of time. So these are data types like int, string, float, etc. Okay, so let's go ahead and write some code. In fact, I have already written some code and I'm going to explain that code to you. Okay, I just did it so that we can save some time, right? So let's move on. Let me open my Google Colab notebook here real quick. So I'm going to explain it for some tensor maths involving constant. So I'm going to explain like tensor in terms of constant. So just to give you an overview, tensors can be represented in the form of constants, placeholders, and the variables. Okay, so we have uh, three types, in fact three entities in TensorFlow, which are very building blocks of TensorFlow. In fact, so one is constant, another one is placeholders, and third one is variables. And we actually pretty much compute the operations on the basis of more or less these entities. Okay, so let me explain one by one these to you. Okay, so first, in the first cell, I have imported the TensorFlow library as TF. Okay, here you can see very well. So I have imported TensorFlow as TF, and in the second cell, I have defined two constants. First one is A, and second one is B, which contains values stored in terms of vector or one-dimensional tensor. So you can see here, right? So these are the constant values. I have defined constant by using tf.constant, and this is a one-dimensional tensor, right? It is a vector. So one-dimensional tensor is nothing but a vector. So you can see here, this is the one-dimensional tensor having three elements. Okay, and the rank associated with these tensors is 1, since it has only one dimension, right? So vectors are one dimensional, that's why we have rank as 1. Okay, moving on, in this particular cell, which is a third cell, right here. Okay, so TensorFlow contains built-in mathematical functions that can operate on entire tensor in one go. So here I'm kind of calculating the sum on these elements. Okay, so I'm calculating the sum on the one-dimensional vector elements given here, right? So the reduced sum will sum all the individual elements of the tensor, and in our case this is tensor A, so it will add all the elements of tensor A. Similarly, reduce prod operation will find the product of individual elements. So these elements are given here, right? 10, 20, 30. So it will basically find out the product of these three elements in the given tensor, and here this particular B tensor, right? So So this is this, and then next what I'm doing is I'm just using the reduce mean function here, right? And the intent is to find out the average of sum of a. So the sum of a is here, right? So we found out the sum here, which is sum of a, and then now and then a product of b is this one, right? So I'm basically calculating the mean or average value of these two, right? Sum of a and product of b. Okay. And next operation is multiplication of these tensors, which are sum of a and product of b. Okay, so you can see that there is another parameter which I have defined in each tensor, which is name. So I'm giving a name to these tensors, specific name. So the name of this particular tensor is a, this is b, then sum of a is this one. Okay, similarly for these ones. So in this one, I'm just multiplying the values of sum of a and product of b values. Okay, right? So we kind of built our graph. So till this moment, till this fourth cell, we have built our graph. So as I told you previously, there are two parts of each and every TensorFlow program. One is to build the graph and another one is to execute the graph. So here till this point, I have built the graph, right? And next step is to execute the graph, which will start from here. So in this section I'm executing the graph. Okay, let me scroll down a bit. Yeah, so here you can see that first I'm using this with clause tf.session as session ses. So here I'm using with clause so that after the end of these operations, it will the operations will be closed by itself. Okay, so I don't need to explicitly close it. Okay, so that's a very good practice. If even if we forget to, let us say, close it, then the program will take care of it using this with clause, right? So we built a graph here, and now the next step is to execute the graph using these statements. Okay, so so the first step is to instantiate the session so that we can execute the graph, and I have instantiated using this tf.session as ses. Okay, so in order to find out the value of any computation, we need to call the session. Okay, session.run, which is ses.run. So I repeat, in order to find out the value of any of computation, we need to call the ses.run. So that's why I'm calling ses.run on A, tensor A, ses.run on tensor B, ses.run on sum of A, ses.run on product of B, and then similarly for mean tensor and multiplication tensor. Okay, so when I executed this cell, okay, you can see the result here, right? So you can see that the value of a, it has printed right away 20 30 40, b is 10 20 30, right, which was defined here, right? And after that it summed up all the values using reduce underscore sum. So 20 plus 30 plus 40 equals to 90, and the in the second this particular computation, reduce, I used a reduce underscore prod, using which it actually multiplied all the values. So 10 into 20 is 2000, sorry, 200, and 200 into 30 is 6000. So it has given 6000. And if you add these two values, if you want to find out the mean, then 6000 plus 90 equals to 6090 divided by 2 is 3045, which is absolutely right. And then I multiplied these two values, 90 and 6000, in this particular statement, right? Ses.run mult tensors, right? So 6 nines are 54, and this you can say 540,000 here, right? So had it been like you mentioned, what I'm trying to say here is, let us say instead of ses.run, you try to print a value directly. So instead of print sys.run a, just you are trying to, let us say, print a value, then you could get the metadata details of computation or tensor. I repeat, if you want to print that value directly, the value of a or b directly, then you will get the metadata details of computation or tensor. So that's why if you want to print the value, actual value of a, then we need to use sys.run, right? So in the case of tensor, it will show you the rank or shape or data type, right? So it won't give you the value of tensor. So in order to get the value, you need to use sys.run. Now you can very well see that the sum of A represents summing up individual elements, and sum of B represented the summing up of individual element of B, right? And then I calculated it further. The values calculated it further, right? So folks, this is it for this video. To conclude, I explained about basic building blocks of neural networks called tensors and its various characteristics, right? Later on, I showed and explained TensorFlow code related to tensor-based computations, right? Folks, let me ask you a question from the video I explained today. What is the shape of an array? Okay, a two-dimensional array, I would say. So what is the shape of two-dimensional array? You can also ask your technical questions in the comment section, so I will be glad to answer your question. So please feel free to ask any question in the comment section given below. So if you're watching this video and you're not already a subscriber to our channel, consider clicking that little subscribe button, and in case you have already subscribed, then click on bell icon to receive the notifications whenever I will release the new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming videos, so keep on watching. Thank you.